Hello everyone. I'm Nikolay Frolov from Kaspersky ICS-CERT, and today I'll tell you about how vulnerabilities in Smart Toy can put your child at risk of abuse by stranger. So, first of all, I tell you a little bit about myself. So, I work at Kaspersky ICS-CERT. That's a team of cybersecurity experts who works with the critical infrastructure. We work with some kind of automotive sphere, with some kind of industrial control system as well. So, industrial IoT and IoT devices. So let's start. First of all, I need to tell a little story how we decide to do a research of this robot. So that is Android-based robot designed for kids age from 5 to 9. Comes with a built-in video camera, microphone, lots of application for education, like math, like learning of languages, something like that, some kind of fun application. And one of our colleagues who bought this robot, he asked us to do some kind of assessment. So that's more than that's more like fun story, not our professional research. But we started with finding some information in vendor site, and vendor state that every byte of family data is protected. So we decide to check this fact, to check this information as well, and my research about it. So we need to decide attack vectors. So we have a toy. So that's Android-based robot toy. That's the first, and the second is parent's mobile application. So that application apply something like connecting. So parent could find some information, some progress of his child in education, some kind of thing. So that's application for control. And one more thing, that is this application make possible to make a call from this application to toy and from toy to this application. So let's start to dive in this existing story where every byte of information is protected. So we started. Yeah. So we start with the just loading the robot, and we try to sniff traffic between the robot and the backend server, and what we saw, so HTTP, yeah. So I'll tell you a little bit more information about this in my next slides, but I need to say that after the update, so to current version of this robot, they changed it to HTTPS, so that's a little bit difficult to analyze it. So we started with robot teardown, so that's easier. We just need to screwdriver to it, and what we found inside. So we found the PCB, and as you can see, the PCB mask tell to us lots of information. So every test point and every chip was signed. I don't think that we often face to schemes with the PCB mask like this. So, when we see the MediaTek MT8167A, so we decided to check some kind of information about the vulnerability there. So, and we found that lots of critical vulnerabilities there. So as you can see, this chip here. So that's make us that probably we found something interesting here too. Maybe without MediaTek vulnerability, maybe with, but so that's the bottom plate. So in robot we have two plates, the top plate that you saw in a previous slide, and there is the bottom plate. So that's not some interesting information here, just maybe this connector. And as I said before, on PCB mask we see that Android here. So we started to, so we tried to connect our computer to this plate, so to this board, and as you see, that's Type-C, but that used just for charging. And when we connect our computer to this connector, so we just see the media transfer protocol. So device just like media device and nothing more. That's upset us, but we try to continue. So we continue with reading the firmware from the eMMC. So that's not something difficult, just using some kind of tools. Because that's eMMC, we don't need to recover some information here, and just using the mount command that you can see in this slide, and we had the full firmware of this robot. And we started analysis. So because we see the USB connector with Android, we start to find some kind of information about it. So first of all, we started with init USB configs. And here we saw something like this. So system USB config, MTP, and ADB. So we think that that's strange, because when we connect it to computer, we don't see ADB device. But we start to find the answer to two questions. The first question, so how we can dive in ADB mode, and the second question, why ADB doesn't work when we connect it with. So first I'll answer to the second question. Because when the launcher started, it used this kind of settings, so default properties, and as you can see, persist system USB config, just MTP, so media transfer protocol, and no ADB here. But we continue. Yeah, and as we understand, we try to do some kind of experiment on the loading, and we try to catch the ADB on the loading, and so we reboot our robot and try to find ADB. And as you can see there, so we got it just for from 5 to 10 seconds, something like this. So that's not enough to make a good research, but we think that probably we could do something with that. So because we have the full firmware of this robot, we decide to find some kind of thing about this in launcher and main application. And we found it. The function that names enable ADB. That functions have property. So they're working with the property enable ADB. So it has two states. That field has two states. So yes or no, 1 or 0. So work or not work. We need to understand where this where this properties was, and that's not a very difficult thing. So in this function, but a little bit earlier, we found that it works with Miko1 properties file. And by default, that field was enabledb no, but we tried to change this file and change this setting. So that's how this file looks like. So it so you can see this some kind of web URL of so that's something like backends of the server, global host token, and lots of information. But in this case, we just need the enabledb field. So we change it for yes. We push it to our robot, and we got the root. So we got the root shell. Yeah. So that's work for just while we didn't connect our robot to Wi-Fi, because when we do it, robot makes a request to server and change the cache properties, so to no as in the server. But for research, we think that maybe we don't need to use Wi-Fi to make some kind of thing. Next stage, that is HTTPS traffic analysis. So that's what I said in the first slide. So there are lots of security issues here. So talking about that. So first security issue, that's in the endpoint login user. As you can see there, that's just 6 symbols password, and the username that was serial number of the robot. So quite difficult to root this password. So yeah. Next thing that we found, security issue number 2. So that's a function, how they generate a password. You can see this function. So they take the serial number. Yeah. They take the serial number at digit and take it in a hex format. So that's something like weak credentials there. So next thing, I think I start with this. So as you can see, the password was 12345, and yeah, we had the access token in this place. So there is no password check here. So yeah. So, next security issue that we found that connected with get application configuration. So first of all, I need to say that they didn't check the access token again. So, and everybody could ask for information of your robot, for example, because here just the serial number of robot, and that's properties that I show you in the previous slides. So that's content not only the information about, for example, backends and some kind of security case, that contains the private information about child, so child name, child age, so all information that you input on first steps, like location, something like this. So lots of private information. Next issue that we found, that is check authentication. Again, 2 problems. So the first problem, that's as you can see, no token, and we got the we got all of this information. So that's something like username, that there is the serial number of robot again. password, I think I tell you a little bit later about this password. So parent ID, again a little bit later. And so parent email, parent phone number. So lots of critical information here. Yeah. And so, and the last thing, last thing that backend was in Django, and debug mode is true. So we got all the endpoint of this API, but they fixed it just when we. So first of all, I think so, but it's very useful for us. So after that, we decide to make a sniff of the how the mobile application call to robot. So that's we think that that is the most interesting case. So because we have the Django backend, we see that. And we got the sniff. We see the first step that's require the Agora token. So we sent the empty request and got kind of this error where they help us which fields we need to use to get this token. So after that, we put the channel name, the serial number of robot again. So they use it, I think, in all cases. And the user ID, so that's just this digit, we take it from our sniff. So again, no authentication here, and we got the Agora token here. So next stage, we need to send 3 fields to Agora API. So the first field, there is Agora token that you see in a previous slide. Next thing, there is Agora application ID. So yeah, that's the same for all robot, and we can find it in the properties file that we got from the get application configuration. So, and the last field, that is channel name, so robot serial number. Yeah. And last step here. So we need to send a call to a device. So again, username, that is robot serial number, and parent ID. I told about it in a slide with check authentication. So that's parent ID from that request. We need it put here, and what we got, what is going on. So yeah, we see something like this on our robot. So we check, we decide to check, is it work with other devices? So we bought the second robot and try to do the same from the our own account, but not connected to this robot, and we got the same thing. So it's possible to make a call to any robot in this system, and just one thing that can defend child from this call. So there is the camera case shuttler. Yeah, so something like this, and nothing more. So, because of this, potential attacker could make a call to any robot as a parent, and attacker might know lots of information about family, and so that's really scary, and I don't think that every byte was secured. Yeah. So, next step, that's with the mobile application. So, as you can see in the check authentication slide, we got the parent email and parent phone number. So, potential attacker could make a request for one-time password here. So, one-time password is weak again. That's just 6 symbols, 5 minutes. So 5 minutes and without no limits for incursive try, that's enough to take the account. So, and in this application, it's possible to unlink device, so unlink robot from parental account. And so, for example, if possible, attacker could get into the parent account, unlink robot from this account. It's, for example, not so scared, but when we first time use the robot show us something like this, letters and digits, and ask to pair him to the account. So, and the password field in this, again, this request, check authentication. The password field includes so these letters and digits. And we found the other endpoint, just not check authentication, generate authentication that makes new password to attach, and it makes possible to, for example, creating new account and connect the robot with new account, and parent haven't got access at all to robot. And I think that just one thing that they gonna do, so that's to use the support and ask for help, something like that. And I think the last thing I'll talk to you about, so that's updating process. So that's a archive. It includes just files, some kind of files. I think that most interesting file, that's .tel file. So what we see here, the file description, where they describe which file to which source, to which target we need to update, and commands. So commands that they execute from the updating process, from root, and for example, potential attacker could, if they try to change the updating file in the updating server, so that makes possible to have a root access on all this, on all robots in the system. So because they haven't got the signature here, they haven't got something here to protect it, and they have just version and just one check that version is higher than the previous version. So what I need to say more, our communication with the vendor. First of all, we report by our policies to vendor, so that's in March 2023. So they accept our report for verification in April. I need to say that that's quite difficult sometimes to report to vendor, because they haven't got some kind of bug bounty programs or other programs to connect with them. We try to do it from the support. We try to do it with support of the previous model of the robot. And so we found a person who who decide to help us and help them in this field. They accept our report in April, so they acknowledge security issues in July. In August, they said us that they fixed all our findings, and in February of 2024, we published the article about this. Last thing, conclusion, I think that first of all vendors and vendors in some kind of critical who works with private information, with child, they need to use security development lifecycle in product development. Next thing that developers should pay special attention to protecting the privacy of children and ensure the safety of using smart toys. And that's very important to teach children the rules of safe and internet with the IoT devices. So something like this. I think that's all. By this QR code, you can read our article about this research. Thank you for attention. And if you have some question, let's ask. Thank you.
All right, thank you very much. If you have questions, please raise your hands.
Do you know if the device uses a secure communication channel to perform the update, and if the robot correctly verifies the server certificate before accepting the package?
Which information? Sorry.
If the robot checks if the robot uses a secure communication channel for the update process, and if the robot checks the server certificates before accepting the update package.
Now yes. So. But,
okay.
But before, there are no checks at all.
Okay. Thank you.
Thank you for the presentation. I have one question. I see some UART port in some pictures. Do you have tried to use it or absolutely not?
Excuse me?
Oh, sorry. My English is quite bad. UART port in some pictures.
Which?
Serial port. Sorry, yes. UART. Yes, my English.
Oh. Which? PCB, okay. Yeah.
Yeah.
I think this one?
Oh. This one, yes. No, the other one.
Okay.
Yes, this one. Do we have to try to use serial port? Because they are visible.
Serial port, which you're talking?
The lower.
This one?
No. Oh, JTAG.
Okay, this one. That's not for main plate. That's for this plate. So that plate works with some kind of driving models and for example, that's robot could dance and do some kind of this thing, and so this port works with this chip, so not with the MediaTek.
Okay, thank you so much.
Thank you. So I think no more question. Thank you all for attention.